All right, today we're going to go over something called the difference quotient. Okay, and it looks like this. Okay, and we're going to start with this piece here, and it says that if you take f of x plus h and subtract f of x, all that's really saying is there's a y value and there's another y value. So it's like y sub 2 minus y sub 1, right? So f of x plus h is really like a second or y value. F of x is another y value, right? So this is still your slope formula here. And then minus, and then your denominator is x plus h, which is the x value that gave you that y sub 2 value, and then minus x, which is the x value that gives you this x sub 1 value, right? Just in a different notation. The one piece to this is, then we can simplify this, and if you take x plus h and you subtract x minus x, you end up with this here piece here, which is called the difference quotient. In calculus, you'll use this again, right? And you'll use this to find the instantaneous rate of change. And I'll quickly just mention what that means. If you take any curve that's not linear, every point on this line has its own slope, right? Doesn't matter, what point I choose, but every point on this line has its own instantaneous slope. What we're going to use this for is to find the slope between 2 points, right? We're going to find the average rate of change. So I'm going to take 2 points, and I'm going to find the average rate of change between that line, right, from 2 points on anywhere in that line. Whether I take those 2 points, or if I choose a point here and here, right, I'm just going to take 2 points on that curve and find the average rate of change, right? Here's this graph of what that means, okay? So if you start with this coordinate here, x, f of x, right? So this is the coordinate x comma f of x, right? This is like x comma y. And then what I'm saying is I have a second coordinate here, right? There's a second coordinate up here, and this coordinate here is x plus h. So take your x coordinate and move h units to the right. So x plus h. And then if I take that coordinate x plus h and I plug into my function, I get some y value of x plus h, f of x plus h, right? So that's all that the notation is. So don't let the notation scare you. That's the easy part. Let's use this, okay? I'm going to find the difference quotient for this example, and I'm going to do this all in parts. So again, I'm going to use this piece here, right? I'm going to use this difference quotient, and I'm going to take it piece by piece. So the 3 pieces I'm going to focus on is f of x plus h, then I'm going to do f of x, and then I'll divide everything by h, right? So in 3 parts. F of x plus h. So we saw from the first unit of this section, f of x plus h, all I'm doing is taking my function, which is 2x squared plus 1. I open up parentheses for x, and instead of plugging in x, I plug in x plus h, right? So x plus h goes in here. And then I'm going to distribute, open it up, and simplify as much as I can. So this is really the same thing as me saying 2 times the quantity of x plus h times x plus h plus 1, right? So x plus h squared, the quantity of x plus h squared, you write that quantity twice, you FOIL, you distribute, and you get an answer there, right? So 2 times, if you distribute all this, you get x times x, which is x squared. When you distribute x times h and h times x, you get xh twice, or hx twice, doesn't matter, just keep it consistent. So you get plus 2xh, and then lastly, when you distribute h times h, you get h squared, and then plus 1 here in the end. All right, so I shortcutted that binomial, right? And again, you do it on the side, do whatever you want. Okay, so I'm going to continue that piece a little bit more. I'm going to distribute the 2 and try to combine like terms. So I got 2x squared plus 4xh plus 2h squared and plus 2. And if you see now, currently, there are no like terms. Okay, that's the f of x plus h part. I'm going to take that function, or I'm going to take that, and I'm going to subtract my original function.
Why is it plus 2 and not plus 1?
plus 1, sorry. Okay, plus 1, thank you. So I'm going to take this, that's the f of x plus h part, and I'm going to subtract f of x. And f of x was my 2x squared plus 1. Okay. Be careful because I'm subtracting that function. So make sure you distribute that negative sign to both the 2x squared and the positive 1. So I'm going to rewrite this one more time. So I got 2x squared plus 4xh plus 2h squared plus 1 minus 2x squared and minus 1 when I distribute the negative sign. There should be some like terms now, and there are. If you notice, 2x squared and negative 2x squared are like terms and opposites of one another, so those are going to cancel out. And I also see one more like terms here. I got a positive 1 and a negative 1. Those are like terms, and those are going to cancel out. So I'm left with, after those cancel out, I'm left with 4xh plus 2h squared. Right? That's everything I'm getting from doing f of x plus h minus f of x. That's my numerator. So 4xh plus 2h squared. And once I've simplified that, I'm going to take whatever's left, and I'm going to divide it by h. And as long as all the terms have an h, so if you notice, I have an h here in the first term, I have 2 h's in the last term, and I have h in my denominator. I'm going to factor out an x from all of them, or cancel an x from all of them, and if I do so, this is going to leave me with, well, the h's will cancel out from here, and you get 4x, and 1h will cancel out here, and leaving me with 1h left. So 4x plus 2h. And that is my difference quotient. In the next example, I'll show you how we're going to use that difference quotient to find the average rate of change. Okay, so I'm going to take this, and I'm going to do it one more time. This time I'll do it with the function x squared minus 5x minus 1. Okay, so this ultimately is going to give you the same exact answer as how we get part A. So how do we find the average rate of change on part A? So let's do this traditionally. So to find the average rate of change, I'm going to use the formula m equals f of b minus f of a over b minus a, which means what? I'm going to find f of 0, excuse me, and I'm going to find f of 6. Plug in 0 for x. What do you get? What's 0 squared minus 5 times 0 minus 1? Negative 1. Plug in 6. 6 squared minus 5 times 6 minus 1. What do you get there? 6 squared, 36. 36 minus 30. And then 5. Cool? So my two y values are negative 1 and 5. So then finally my slope is going to be, well, I'm going to do 5 minus negative 1. Right? So subtract my x values. And 6 minus 0. 5 minus negative 1 is just same as 5 plus 1, which is 6. And 6 over 6 is just 1. So option number 1 of doing this, right? That's probably the easier route right now. For now. Now I'm going to try to get the same slope of 1, but this time using the difference quotient. All right. So B and C, I break it, B, C, and D, I'm breaking it down to all the separate pieces. So again, part B and C is my numerator, and then I'll divide everything by h. All right, f of x plus h. Take my function, f of x plus h, and I'm going to open up parentheses everywhere I see an h. I'm sorry, an x. And I'm going to substitute in there my x plus h. x plus h squared, again, remember, is just x plus h times x plus h twice, right? Make sure you FOIL and distribute and all that good stuff. All right, and if I FOIL and distribute that, I end up with x squared plus 2xh plus h squared. If you want to do that on the side somewhere, do it on the side somewhere. Then I'm going to subtract, keep going, I'm going to subtract this -5, distribute -5 into x and h. So minus 5x minus 5h, and then minus 1 here in the back. Right, that's just me plugging in x plus h into my x. I had to square one of them, and I had to multiply the other one by -5. Okay, so that's part of my numerator. The second part of my numerator, I'm going to take all that, and then I'm going to take this, what I got, and then I'm going to subtract my original function from there. So I'm going to take what I have, and I'm going to subtract, and I'm going to put this in red to make sure you distribute. And my original function we said was x squared minus 5x minus 1. So x squared minus 5x minus 1. All right, so that's f of x. By distributing that negative sign, I'll just rewrite this one more time. So x squared 2xh plus h squared minus 5x minus 5h minus 1. And be careful here, distribute the negative, minus x squared, positive 5x, and then positive 1. What are like terms that can simplify? I'll highlight some of these. I got x squared and negative x squared. Those are going to simplify out. What else do I have? I have a negative 5x, a positive 5x. Those will simplify out. And one more. I have a negative 1 and a positive 1. And those will cancel out as well. So I'm left with 2xh plus h squared minus 5h. Okay, so I got 1, 2, 3 terms left. And I'm going to divide this all by h. And this is step D, or part D. Notice every term in the numerator has an h. So I'm going to cancel out an h from everything, from the denominator and the numerator. So 1, see you later. This one has 2, so I'll be left with 1. And this one only has 1. So I'm left with 2x plus h minus 5. This is my difference quotient. Right? I'll put dq here. Now I'm going to use the difference quotients to get the same average rate of change that I got from part A, which was just 1. The interval is 0, 6. Okay? So I have two values here. I have h. And the h value comes from the interval 0, 6. And the question is how big is this interval? What's the distance from 0 to 6? How many units are between 0 and 6? 6 units. So h is just equal to 6. Right? It's just how many units are in the interval? 0 to 6, there's 6 units. Okay? And then your x value, right, we have to plug in for x. X is going to be your first x value in the interval. So x is just going to be 0. Right? So your x value is going to be just the first value of x in the interval. The h value is the difference between 0 and 6, right? If you count from 0 to 6, 0 to 6, 6 units, that's my h. Right? Hypothetically, if this is -1, comma 7, then what would h be here? How many units between -1 and 7? 8. Okay, that's all h is, right? How big that interval is. Okay. So now you have that piece. So you got h is 6 and x is 0. I'm going to go back to that difference quotient that I found, and I'm going to plug in 0 for x. I'm going to plug in 6 for h, and I'm going to simplify. It's 2 times 0 is 0, and 6 minus 5 is 1. So what's the average rate of change on the interval of 0 to 6 with an h value of 6, with an interval length of 6? 1. Right back verifying what you got from part A. Questions? Okay. Example 5. Find a board space. Let me see it out. This one's cubed, so be careful.